And now onto the main event. We're talking about AI search in Drupal. This is being presented by Foster Interactive. We're a UX focused digital agency working in the B2B and higher ed
Yeah,
spaces. Oh, and so if you are interested in web development, please reach out to
yeah,
us.
it's 647.
Oh, there we go. We can mute. And without further ado, I'm happy to introduce Scott Euser, Director of Web Development at Soapbox, who will be presenting today. He's the co-maintainer of the AI module. And as I sort of said before, there's like a lot in the AI module. So this is primarily the AI search zone within there. And Scott is working at Design by Soapbox, so you can check out their website there, as well as Scott's Drupal.org user account as well. So Scott, I'll hand it over to you.
Thank you very much, Aidan. Yeah, let me take over sharing screens then.
Sure.
Yeah, so I'm not going to do full screen because I'd like to do a lot of live demoing and stuff and show you how different things work within the AI sphere around AI search and vector databases. But first, I want to start with talking through general concepts. I'll try to whip through it fairly quickly so that I can get into the sort of demo and show how things work. But feel free to reach out to me after if you've got more sort of clarifications or questions. So as Aidan said, I'm the Director of Web Development at Soapbox, but I'm heavily involved in the Drupal community, maintaining lots of modules, of which the AI search submodule is where I focus within the AI module itself. I'm also involved in things around AI translation, things like that. But yeah, today's presentation is to talk about what is AI search, understanding the concepts of it, how to set it up to make it work well, where it can easily sort of go wrong and gotchas and things like that, how it can be useful in your sites today. I'm particularly looking at this from a visitor-facing perspective, things you could show to end users. I know a lot of the things within the AI module are around helping developers get tasks done, helping content managers get tasks done. But I think it's quite important to also think about what we can do for our users. And then, have a discussion as Aidan said, Q&A, things like that. So let me talk through what a vector database is and what the AI search module effectively does. So the AI search module is meant to be a sort of underlying framework to connect your Drupal site via the Search API module to a vector database. So there's a lot of terms in there. Search API is a heavily used module in the Drupal community, now part of the Drupal CMS as well. And it's designed to index your content, but you can index it different places. The default thing is indexing into a database, but it's also possible to index into SOLR, other community modules like TypeSense and things like that. And what we're focusing on today is indexing into vector databases like Pinecone and Milvus, which I'll show how they work. So the goal of AI search is storing the semantic meaning, or the goal of vector database, storing the semantic meaning of the content in the database instead of keywords and keyword matching. So the way that a database search works is doing a sort of scoring. So if you type in a search term and you want to get results back, it's effectively looking for how frequently that search term appears in your content and giving it a score. So for example, if you have content where the title has the word appear, maybe it gets a score of 3 for each time the word appears. Maybe if it's in the content, you get a score of 1. A content item then gets a score of 10 in total, and that gives it a relevance compared to other things. And that's a very sort of raw way to find content, but it assumes that your users know what you're talking about and use the same terminology as you do. It also assumes that they enter just a couple keywords rather than a question format or anything where it's more about the meaning instead of the word frequency. So if you use a typical database search in Drupal, you've probably come across users complaining about your search, wondering why you're not getting relevant results. AI search is really about getting much better relevance. So we're capturing a lot more information about your piece of content, thousands of dimensions about it. So not just sort of descriptive things. It could be the emotion behind it, sentiment, tone, size, all this sort of information. You can see in this little diagram, it shows that different sort of, in this case, animals are closer to each other because they're more similar. So a wolf and a dog are kind of closer together. So maybe if someone would search for a dog, you might get wolf articles if you don't have things about a dog. Whereas if somebody's searching for fruit, they're going to get things like bananas and apples and not kittens and dogs. And it's about getting, you know, what is closer in its semantic meaning as results. And that allows you to kind of avoid the reliance on users knowing keywords. A side sort of benefit of having AI search as well is there's an AI logging system you can turn on, which allows the site to record what people are searching for, particularly when you get to vector database-based search. AI search, people can ask things in question form. So I'll show that in the demo. When they ask things in question form, it gives you a lot of interesting insight about what do people actually want from your site? What are they looking for? And that can guide you for writing new content or updating your existing content as well. So it's got a sort of side value as well to it. There's a lot of detail that goes into it. So I'll try to talk about how we set it up effectively to make it useful and get good results in the demo. So yeah, this little quote: users don't know what they want, they can't articulate it, they don't know what's possible, and they don't know the terms you use for things. So they're not going to find your content if they don't know your site intimately. They're gonna fail. AI search is also really good at finding the right content and letting a large language model produce something like an AI overview. This was actually coming from a search in ChatGPT asking about a quote from Steve Krug about search relevance. And it made up this quote. This quote doesn't actually exist. He never said this. And that's one of those things that goes wrong when you allow a large language model to give you an answer without it being based on evidence. Whereas vector search allows you to do what's called retrieval augmented generation. So that's passing content that you've retrieved from your site and getting the large language model to answer using that content. So instead of getting the large language model to look at its training and make up something, based on what it thinks Steve Krug might have said, it actually is given, here's the content of 3 articles in the site. This one is written by Steve Krug. Get a quote directly from it. Don't change it, things like that. You give this kind of instruction to your prompt, and then the AI overview that you generate or whatever your sort of chatbot or tool that's being used can have a much more accurate result without this sort of hallucination in there. So that's called retrieval augmented generation. It's a sort of concept, but it's effectively what the AI search module underpins and allows you to do. So it allows agents to find content within your site to be able to carry out actions, but it allows you to use views and search to generate answers to questions and these kind of things. So I'll show you some examples, practical uses of this. But yeah, the concept, if you want to read more about it outside the sort of Drupal world, it's called retrieval augmented generation, and there's a lot of articles and information on it. So yeah, a few practical visitor-facing applications for visitor-facing sites. So the easiest one and the sort of direct one without any other implementation is just far better relevance. It's just much better, which I'll show in a sec. But you can also use it for things like related content. So instead of just sort of matching on tags and things like that, you can find actually relevant related content using, instead of the user's query trying to find similar results, you're effectively passing the current piece of content being looked at to the vector database and retrieving similar results. So you could use it for automatically featuring content on a topic, maybe context-aware promotions, personalizations, and other things like that. So lots of options with it. But yeah, without further ado, I'll just show a bit of what I've got set up. I'll do a setup from scratch if I've got time, just to kind of talk through all the details and how how to get the setup right. I just want to show what I've set up here. So I've set up a default search API database index. I've set up a Milvus index. So Milvus is one of the AI vector database providers that a number of us maintainers, co-maintainers of the AI module support, and Pinecone similarly is a vector database provider. So Milvus is quite a handy one because it has a DDEV version as well. So if you're a developer, you can use this sort of free open source version locally without having to have any fees. Pinecone is also, if you're less of a developer, you want an easy interface, Pinecone has a starter version. And the starter version I found even works fine for sites with 5,000 pieces of content. So actually you can get quite a lot of mileage just with the free version of that. So it's quite easy to set up. And Milvus has this sort of hosted service, software as a service equivalent called Zillis, but the Milvus module works fine with that as well. So these are the vector database engines. These are similar to installing Search API SOLR or TypeSense or any of these other sort of tools, except you install the Milvus or Pinecone one. There's more specific details on where to find the module and installing them off the AI homepage. You'll find the documentation links there. But yeah, like I said, I'll try to talk through it. So I've set up these Search API servers, and then I've set up some views to be using those servers. So I've created effectively 3 search pages, one using the database as the source, one using Milvus, and one using Pinecone. So I've got my database search here. I've just added a tags filter. I didn't do any styling, so it looks a little bit, sort of broken, but I've got this Umami website. I've added a little bit of extra content to it just to kind of be able to play around. But if I do a search, for instance, for something based on keywords, so I've added some train articles. I know I can find something with the word train in it. Fine, it gets me something. But if I start comparing that, let's say with this Milvus one, you can see I found an article already that didn't get found by the database one. And that's because this particular article doesn't have the word train in it. It's talking about railways. It's a very similar topic, but it didn't find it. And you can already see it's starting to go wrong, even with the simplest example. Pinecone, same thing. So one difference with Pinecone is they won't actually find contents for you until you make a search. So it wants to have something to compare with. But once you have that, you can see I found even more options here, all sort of relatively related to, trains, railways, rapid transit, subway, things like that. It's getting more and more results. Part of this is based on how you configure it. So I don't want you to give the impression that the Milvus is inferior or something. It's nothing to do with that. I've just configured them slightly differently with different sort of thresholds of relevance, but both of them would perfectly fine get good semantic results. But where this starts to fail is if I, for example, type in the Pinecone things that move on 4 wheels, or let's say multiple wheels, because that'll be like a train, right? So I can still get good content, things that move on multiple wheels. Milvus, that will fine. But if I do database, nothing. So if I don't know exactly what the content's about in this site, I'm not going to find anything with the database search. It starts to fall over, and then you start getting complaints from your users, or they just go to Google and search instead, trying to find something in your site, possibly, but also possibly going away to competitor. So, lost opportunity there. So you can see, like, as soon as you start getting beyond sort of basic keyword matching, you'll start to not get any results. So if I did something, even with keywords, locomotive, okay, that one has the word locomotive in it. If I spelt it wrong, let's see, nothing. Or if I spell it wrong here, still got results. Spell it wrong here, still got results. So you can see that it kind of compensates for user error as well, things like that. But yeah, once you get logging in place, then you start seeing also what are the users searching for when it comes in question format. So in these cases, I've still got a sort of little keyword input type thing. But what you see a lot now in search is when they have a vector database behind it and they can generate AI overviews, you put a bigger box here and you put a prompt that sort of makes it look like a question. and then people will ask a question instead. So here's an example of the Nuffield Trust. This is a healthcare think tank in the UK. And here you can see we've got a big sort of question box. And when you've got this big sort of question box, you encourage the user to ask a question rather than entering a search term. And I could say, are patients satisfied with the NHS, so the National Healthcare Service? And in this case, I'm going to pull up relevant results and also generate an AI summary with the content. So it's not making things up. It's actually citing sources. All these sources are now appearing on the side, and the user is being encouraged to provide an answer. What's happening here is effectively making sure that we're indexing the client's content effectively, only what we should be indexing, prioritizing, in their case, recency, because in their case, it's important to have new information and not cite old articles. So that's something that's being leveraged, and giving the AI clear instructions on how to answer, what tone of voice to use, how to phrase it, how much detail to provide, putting things in bullet points, structuring it as markdown, only using information it finds, and citing sources, never making something up when it doesn't have a source, and also encouraging it not to do calculations or dates or numbers, because that's the type of thing that it's going to get wrong more often. So just telling it to give sort of rough information and encourage the user to read more. So this is using AI search module. In this case, not a sort of combined thing, but I'll talk about how we can do that. But it's also generating an AI overview. So I'll show how we can do that as well. So we saw here that we've got the database failing. Now there is a way to use the database search. So where database, SOLR, and other search providers do really well is structured content. If you've got, I don't know, 10,000, 100,000 pieces of content, and you've got, let's say, lots of different tagging, filtering, tons of sort of exposed filters in your search view, you want to allow the user to be able to get all those 100,000 pieces of content, potentially narrow them down with filters and things like that. The vector database is very good at relevance, but it's not good at quantity, getting a high volume. So it's going to give you top results back, closest matches, but it won't give you everything, and it won't handle the filtering very well. So within Milvus and Pinecone, we've got some level of filtering because it does have some support for it, but it's much less feature rich than what you can do in views in terms of filtering options. So you'll start to see, if you try to do directly more filtering, this works fine with like a simple one. But if you want to try to do something more advanced, it'll start to creak at the seams, and eventually you'll hit areas where you'll get frustrated because the exposed filters aren't working. So this is where we've got the option to combine the database and SOLR views. There are other ways to do that, so I'll show this way, but just to be aware, there's a lot of effort going on, for example, around the TypeSense community that has a combination of what they call a hybrid search. So it's got the semantic search as well as the structured content. SOLR is working on an implementation, so there's an issue in the Drupal queue for the SOLR module where some people have been contributing to that. I'm not sure what the status is. The last I checked, it was kind of in progress, where you might be able to get this combined side of things a bit easier. And there are other tools as well, which are working to try to kind of do this sort of hybrid search, but without having to use any of these sort of services, which some of them can be paid, and a lot of them do a sort of freemium model where if you use the vector database side of things, you start to have to pay more rather than, let's say, their free versions. And this kind of thing can work in a free scenario. So combining the database and a vector database. So if I want to go to the configuration of the database index, I can go into our processors, and we've got this plugin within the AI search submodule. It's called Boost Database by AI Search. And that's opened up some settings here. So I can say, okay, I want to use Pinecone to help me find results. I want a minimum relevance score. So the score is between 1 and 0. We're trying to provide a lot of detail in all the field descriptions everywhere to help make it more understandable, and the number of results to return. So what we're going to try to do basically with this is augment the database search results to find results that otherwise wouldn't have been found. So still allowing the database search to apply filters to deal with hundreds of thousands of pieces of content, but getting the top results on the first page to be sorted in a priority that comes from the vector database, as well as finding things that otherwise wouldn't have been found. So dealing with typos and things like that. So let's just see if that worked fine. So now we see we've got the results that I would have got from the Pinecone one with my typo, yet I'm using the database as the source. And so it's found things that didn't otherwise exist. So that's a sort of simple way to get the best of both worlds with your AI search setup. I'll move on to using, instead of somebody's keywords to find relevant results, I'd like to find relevant results looking at an existing piece of content. So I'm going to take the AI related content module. This is a pretty simple module. It's not trying to do anything special. It has very little code in it. It's more just to kind of help set up a view in Drupal, because it's got a bit of nuance, a lot of gotchas, and a lot of things where you can easily sort of misconfigure and then wonder why you're not getting any results. But the idea here is that it sets up a view that you could stick on the bottom of your article page that could be like recommended next reading, something like that. And you can put that block wherever you want, and it'll find relevant content related to the thing you're looking at rather than based on a user's query. So I'm just going to enable that module. And what it has is, go to the AI here. And we've got this AI related content view setup. And so what this does is it basically looks at the search API index that you've created, so your sort of vector database one, and then automatically sets up a view based on that. Once it sets it up, you can export it and do what you'd like with it. So I've created this new view. So I'm going to go to my views, and I'll edit this. And I've got no results here because I need to give it some context. So if I put this view as a block on an article page, it will give me the related content based on the thing I'm looking at. But let me just take a piece of content here. So I've got node 36, and I'm just going to give that as context. And I can see I found then other pieces of content that are relevant and related to that one. If I take some other, let's say, umami recipes, so I think we've got, here's one on oatmeal. So that's 18. So this will do, you don't have to do this obviously if you're the end user, it's doing it for you based on the context, but just so I can show you in the backend demo. So in this case, it didn't find me something relevant. But yeah, that's the idea, that that you don't have to be stuck with sort of using it in a search context. You can also use it for generating related content. There's another module that kind of does this sort of AI summary, AI overview, as you see in Google, called the AI search block. I haven't been involved in this one, but obviously done something similar. So this one was, I think, mostly written by Wouters F. Let me just enable it. Set it up, I guess. So this one comes with 2 blocks you can add to a page. So I'm just gonna, let's see, we'll add it to the bottom. Replace the AI search block. It's got some settings you can configure here, but basically to get that sort of streaming answer, you can start with the defaults and then decide to use something else. One thing you do need to set is setting up a what's the source. So I'll just use Pinecone index again. I'll set a lower threshold just to make sure I get some more results. And it's got the ability to sort of change the prompt if you'd like to decide how you want it to answer. So like I was saying before, giving a good example of what you expect it to answer in the format you expect, how concise you want it to be, what you want it to do when it doesn't know the facts that the user's asking for. That kind of thing is the kind of instruction you want to put there. And that's going to be a bit contextual towards your site. So put the AI search one. It comes with a second block as well, which is the response. So this is where once the user asks the question, the response is going to be put into there. I think I set it up. Let's see. So tell me about elevated trains. And so you can see some answer that it's found from the elevated railway article that I had before. And that's a simple way to provide a sort of AI overview answer. So there's a bunch of configuration options in there worth digging into, kind of playing with more, but it's also a good example in case you want to do your own solution. You can follow along with how they set up the code to see how to kind of do it yourself. There's also sub-modules within the AI module around like doing chatbot and things like that, which also leverage RAG search, AI search, and particularly in 1.1 that Aiden was saying that the performance of that has gotten quite a bit better. I think Marcus did a lot of work on getting the function calling to kind of work more reliably. So it'll actually call the vector database, find relevant results, and then answer the user's question more reliably than it did in the past. I haven't been very involved in the sort of chatbot side of things, but worth exploring as well if that's the kind of thing that you're looking for your site. The last thing I wanted to go through today is just showing how to set up a new index and talking through the sort of gotchas and the things to look out for. So I'm going to set up a new server. I'll set up a Pinecone one, and I'm going to use the AI search backend. So there's a bunch of decisions to make here. We've tried to put a lot of detail again to kind of explain how they work, partly for power users. But one of the things you need here is basically an embedding engine. Sorry, one second. So the embedding engine is provided by one of the large language models that you'll have installed when using the AI module. So for example, OpenAI has a number of options. These have different costs involved. So they're quite cheap. So for example, the Nuffield Trust website, I think indexing their entire site of 10,000 pieces of content or whatever was under $1. And each time somebody runs a query, it also has to convert what the person's asking for into vectors in order to do this comparison and find the nearest results. And that costs a fraction of a penny, each time you run it. So I think their cost per month are well under $1 for running it. And because the Pinecone instance is free, they don't have to pay for that type of thing. So yeah, you could select a different embedding engine. So a larger one is going to give you, in general, more accurate results, but slightly slower. So a larger model is generating more dimensions. So that means more detail about each chunk of content. I'll talk about chunks of content in a second as well. So I'll just set it this one. The tokenizer is not particularly important. This is more about the AI search module deciding at what point it should break apart a really long piece of content into multiple chunks. The reason that we do chunking, and this is not a Drupal specific thing, this is the way that it's kind of recommended to do in the wider community, is breaking the content up into smaller bits. Because if you have let's say 100-page article and you're doing a couple thousand dimensions about a 100-page article, a lot of the meaning is going to be lost and you're not going to get good results. So if you break that apart into, let's say, chunks the size of each page, then you'll get much more relevance because each page is effectively going to have all those thousands of dimensions. And overall, your whole article is going to have maybe tens of thousands of dimensions that capture the semantic meaning of the content and allow it to be found. When you're using it for search, it's then combined back. So for example, if it finds chunks, let's say 20 chunks from that 100-page article relevant to a particular thing the user's querying, it knows that, okay, that's all belonging to one node in your site or one piece of content in your site, and therefore, that's one result. So it's not, the chunking is not hurting, or making duplicate results coming back or something like that. It's just about making sure we don't lose too much meaning when we're indexing your content. And I should select a vector database. So the vector database is a submodule that you're installing, or not a submodule, a separate module that you're installing, like Pinecone or Milvis. There's a couple other backends. I think Josh, I can't remember his last name. Apologies. From Numico, I think it is, has been working on a Postgres one, which could be used. But yeah, lots of options here. So I'm just selecting the Pinecone one. The Pinecone one is kind of trying to do the work for me by selecting the indexes I've created. So I'm going to just create a new index. So I'm in the Pinecone interface, and it basically just has this.
I don't know if that's me or.
Uh-oh.
Oh,
You're back.
I'm back.
We lost you there. I cursed it because we talked about the internet
Yeah.
before the session. All right. So you were we lost you at creating the index.
Okay, so you get into Pinecone, and it'll ask you to sort of create a new index. I can select one of these sort of automated configurations. If you are using your sort of a different provider, there's a manual configuration option. But I'm just going to select the thing that I selected when I was creating the server over here. So I had selected. You can see it there, text embedding large. So I'm going to do that here, demo server. Okay, fine. I'm just going to do it like that. And everything else is kind of fine to use the standard because that's going to give me just a free, basically, thing. It's telling me how many dimensions it's going to do. So 3072, fine. So I'm going to create that index. It's got no records in there. It's pretty quick to do though. And if I refresh here, let me select that again. So I've got my demo server there. I'm just going to call it demo, and I'll leave the same cosine similarity. So it's not a Drupal thing. It's not even really an AI thing. This is a ancient math that's been around for decades, I believe, which is basically just calculating the distance between these vectors. So vectors are a numerical representation of your content, and you need to find in this sort of 3D space the closest results, and that's how it's using finding the results. There's a bunch of advanced options here, but we've tried to set it up so that it just automatically picks a recommended strategy based on the index you selected.
Scott, so a good question. Just what? So what? I see from chat. Why do we have to select the engine twice?
So I did this a second time because I refreshed the page because I created the server
Okay.
after. So I basically.
Sorry, no,
Go ahead.
Sorry, I meant why do we have to select it both on Drupal and on Pinecone? And what would happen if we select different engines, either side?
Yeah, you won't get good results if the dimensions don't match effectively. So if you query with, let's say, I don't know, 1,000 dimensions and the index is storing 3,000 dimensions, I think you probably won't get any results because it's basically just indexing it completely different. It's like speaking different languages effectively. So it's really important that they line up. Yeah, if you change your model to use, let's say, a small text embedding instead, then you need to reindex the content effectively in order to get good results. Does that kind of make sense?
It makes sense. I just don't. So, because who's in the end talking to like OpenAI, for instance? Is it Pinecone or Drupal, or both?
So Drupal is. So Drupal is basically taking the content from the search API, sending it to OpenAI and saying, "Give me a vector representation of this content." And then once
And
you
then
have that vector representation, so those numbers, then you pass that to Pinecone. So Pinecone, it has actually facilities to also create vector representation, but let's not get into that. It basically is just accepting the giant array of numbers, so thousands of, your 3072 dimensions here. It's accepting that array of numbers and stores it in its database, and it's a specialized database that's allowing it to do this vector lookup. When you want to search it, then you have to again take what the user's asking for, or what the AI related content is generating, or whatever the tool is, and you have to pass it through that same algorithm, that same thing to OpenAI, and say, give me back the vectorized version of this content in order to query it. And it needs to be done in the same way in order to basically do an effective search.
Okay, perfect. Understood. Thank you.
Yeah.
So in the end, Pinecone and those, I'm just not very familiar with those vector databases. So they're actually not doing any like large language model stuff. They're just doing like mathematical calculations with vectors.
Exactly. Yeah. Except that Pinecone has been dabbling in some of those things. Whereas more of the vector databases are kind of just focused on the vector database side of things, so more about the storage. But Pinecone, you don't have to use their extra features. They're trying to do it as a sort of, I think that's their kind of freemium model. They want you to use like their generation of the vectors, and they have re-ranking strategies and things like that, which I don't think I should get into at this point, but they have a lot of other features you could add on top. Yeah.
Yeah, very interesting. Thank you.
Yeah, no problem. Yeah. So there's a couple of kind of nuances in here. So this embedding strategy, this is about how we're generating the information for each chunk of content. So if we've got this piece of content that we've got hundreds of pages of, if you would index just each page, you can imagine that maybe a page without having what's this whole article about kind of loses its context, and it could mean something completely different out of context, and that's a danger as well. So this is where we get into a chunking strategy, where we want to have each chunk of content have an element of what the whole article is about. So what that means is, let's say page 1 takes, I don't know, the summary of the article, the title of the article, and some other information. And each time you create the chunk, you have that title summary, page 1, title summary, page 2, title summary, page 3. And that way, each bit of content that gets vectorized, that gets prepared for putting in the vector database, has a more accurate representation of the article as a whole as well, and not just that chunk of content. So that's effectively what this is trying to do. So if I take 500 tokens, so the easiest way to explain this is, which is very inaccurate, is tokens are kind of like syllables. So they're not words, it's not characters, it's something in between. So you can kind of consider the length of a piece of a chunk based on that. So if I said a longer chunk, I'll have less dimensions for that chunk, but it'll have more information and less chance of being taken out of context. So that's where it's important to kind of look at your content and see, is it, for example, very long-winded? Maybe you need a bigger chunk size. Otherwise, you're going to miss too much context and you'll lose a lot of the meaning about what that page is about. Whereas if it's a very concise bullet points, things like that, maybe you want smaller chunks. And that might depend on how content is typically written in your site. So it can get a little bit complicated there. And this is one of those things where you can play with, you can change it later. So you can't change the dimensions, but you can change the chunk size. The contextual content is basically trying to figure out how much of that one page do we set aside for that title and summary to be repeated every time? And the overlap is, let's say an important concept is starting on the bottom of page 1 and continues on to page 2. We want to take the last bit of page 1, carry it over into page 2, and so on. And so that basically each chunk has a bit of overlap from one to the next to not miss or cut like a sentence in the middle or a paragraph in the middle, to reduce the kind of risk of that, to reduce the risk of again, missing some semantic meaning. So these are kind of things you can tweak based on your content, but we've tried to set up sort of recommended defaults that work well for what we see as most cases. But it's it's hard to get this perfectly, but yeah, so something to play with. So in this case, if I've increased my chunk size, I could increase my overlap without too much pain. Whereas if my chunk size was 500 and my overlap was 300, I'm going to get a lot of chunks because most of my content is going to be overlap, and very little of it is actually going to be the next chunk of content, next page of content. So I'm going to set that up like that. And it basically does some checks, make sure that everything is okay. There's a lot of warnings that will pop up if things aren't okay, if something's misconfigured. We've tried to put, explanatory text of, okay, what could you do to fix it? What's going wrong? With things like Pinecone, because it's sort of all configured for you via Pinecone UI, it tends to go pretty smooth. But with other ones that are a bit more sort of DIY solutions, it'll be checking things like, do the dimensions match? These kind of bits of information that like we were just talking about before, you're not going to get good results if those key bits aren't there. So we're trying to kind of capture that in there as well. Then within the server, we need to, so I've got this demo server here. We need to create an index. So I'll do demo index. I'm just going to index content. I'm going to do all my content types. That's fine. And I want to use that demo server I created. The only thing I would kind of suggest is just have a smaller batch size when you're indexing, because generating embeddings, so that's the vectorized semantic meaning of your content, takes a bit longer than it would if you're just indexing via database or SOLR or something like that. So I'll set that up as a lower amount. And Search API then comes up with what you want to index. So this is the standard Search API thing, regardless of what type of database you're using. So I'm just going to add some fields in. I'm going to add the full rendered HTML. So I'll do full content. What you want to probably do, though, when you're setting this up is really care about what view mode you're doing, to make sure if the full view mode of an article contains related content, contains, I don't know, sidebar information, things that aren't relevant to the actual piece of information itself, you probably want to use a different view mode. So maybe curate your search index view mode, create a different view mode, something like that, so that you're only getting the real content of it and not extra information around. Otherwise, you're going to get misleading results. If you, for instance, if you're indexing the related content, you're going to get the related content then as a chunk and as part of the vector representation, and you're going to wonder why you're getting some unrelated article as a result. So just kind of be careful about that one. I'm doing full content just for simplicity here, but you really want to make sure what you're indexing is really just the content. I'm also just going to add title, so I can add some contextual information and show you how that works. And I'll add tags. So this then takes me to a slightly customized version of the fields page in Search API. We've tried to provide information here about the different types of indexing because, as I had mentioned before, the vector databases do have a minimal level of support for filtering. So for that kind of thing, I can say that this is a filterable attribute. And then Pinecone and Milvus have a limited level of support for it. Then we've got the contextual content. So that's the content we want to repeat on every chunk. So page 1 having the title and summary, page 2 having the title and summary, and so on. That's what you'd add as contextual content. And you want this sort of main content. That's the big chunk that's going to get converted to smaller chunks and vectorized. So I'll save these changes, and I just want to show one more thing here. if I search for a piece of content, I can see what it's actually sending to get vectorized. So I can see here, it's rendered the full view mode. It's rendered a bunch of tags, dates, things like that. And I can look at this and see, well, is there anything here in my content that I'm indexing that is not sort of representing what the user is going to be looking for? Actually, this looks okay. Maybe I might want to, have a view mode where I'm excluding the author, because maybe that's kind of negatively influencing the semantic meaning that gets stored. I've also got 2 titles here, so maybe that's not great because the full view mode's got the title, but then so is my contextual content. So these are things where you can decide to tweak the information. And then you have the indexing, which should just go. And if I open up the vector database, once it gets going, so you can see it takes a bit longer to index. So obviously if you're running this via like a cron job or something, it makes it a bit easier. And you can see straight away in Pinecone, it's loading up the different contents into here. You can see a rough representation of what's getting stored as the content. And you can see here, these are chunks all from node 11, node 11 again, node 11. And you can see it's added this contextual content to the top. You may also notice that it's doing a sort of markdown representation of this. So that hash in the top is the title. Large language models do understand markdown, so they get a bit of semantic meaning from that. Headings and things like that having slightly more influence. So this is getting indexed in, and then I can use it to set up a view, which is essentially structure views, and then adding a view and selecting our demo index. So that's setting up AI search in general and using it in views. We talked about the AI-powered search block, which you can use, the AI-related content. We touched on a bit of things like you can use it in like AI agents, automators. There's other sorts of uses. So the AI search is a sort of groundwork framework module that helps you do these kind of things. I think I've gone over into the question time a little bit, so I'll stop talking. Thanks for bearing with me. I hope it was useful.
That's amazing. Thank you so much. Super. I have like 12 questions, so I don't want to take up everything. But one quick question. Could you show us the logs where the queries go? That would be, or just point us in the right direction if that's because that sounds like that'd be really useful to be used for testing, right? Because how do you test it, right? Find out what the queries are and then run them over and over again, I'm guessing.
Yeah, exactly. So I think this is not maybe the most useful because this is doing all the logs. So this is also giving like the embeddings logs. If I would do a search, let's see, is that gonna pop up straight away? So it's not the most representative thing. I'm not sure if the AI search block would be giving it back there. When we set it up for the Nuffield Trust, we've got a bit more detail in there. Maybe I can. So there was the question I asked during the demo. It said, are patients satisfied with the NHS? It said the answer it gave, sources it used, prompt template it used, that it was OpenAI GPT-4 Mini.
Cool. Awesome. Any other questions? We got 2 minutes. I'll ask a quick question. If not, I will.
I have a quick question. Just do you have any examples of these things being used in the public sector in Canada? I work for the city of Vaughan, so that's why I'm curious. I have some ideas of how I would implement that on our website, but just curious if you know anything cool.
Yeah, the Nuffield Trust website is the most public sector
Mhm.
one I know, but I'm based in the UK. I'm originally from Toronto, actually, but it's been 20 years since I lived there. So yeah, so I don't actually have any like clients in Canada. So yeah, um, yeah.
Any other questions?
Okay, thank you.
Nice.
I got a quick one. Is there weighting by content type available? How do you mix and match the content type weights?
So with the boost, it's a bit basic because it's basically putting the like the priority to the boosted content.
Yeah.
But that could be tweaked. It would be possible to extend. Um, what we've done for things like Nuffield Trust is custom search API processors to basically affect the score afterwards. So to basically apply like a I think reverse logarithmic function on to make the scores decay when it gets older.
Yeah.
So something that's like 1 year old, much more relevant than 2 years old, but actually the difference between something 5 and 10 years old, not so much. Both are old. So yeah.
Yeah. Amazing. Perfect. Well, thank you so much. That was an awesome session. I've got a long list of things to work on and test out. Very excited to try that out. Also happy to hear like it wasn't super expensive. I was like afraid of Pinecone and be like, what does it cost? I'm like, we'll load in a bunch of stuff and get a $5,000 bill, like maybe. But it's
Yeah,
good.
no, their free is quite the free is quite generous, and because you can limit yourself to free, you don't get a surprise bill uplift. And with OpenAI, there's all sorts of limitations you can set. So you can set like auto renewal of like auto top up or whatever of your credit, but then you can also say I only want it to maximum top up this amount per month, these kind of things. So you can really limit your large language model side of things too. And the vector database stuff is quite cheap in comparison to like generated content. So the text is more expensive to generate than the vectorization.
Perfect.
Like what's the proportion of the cost? Like you said, you guys like you use an example like of paying like less than $1 per month, I think, for the Pinecone.
Yeah.
And then how much of that would proportionally be to OpenAI? How much would you pay?
I think 100% was to OpenAI because the vectorization is happening via that too, and Pinecone's fee was free because they're fine in the starter. But the mix between like the chat endpoint, which is what's generating the overview, and the vectorization, I think it was something like 75% maybe is the AI overview side of things, and 25% being the generating the vectorized the embeddings. If you re-index your content, then you'll have a slight surge, So that was what I was saying. Like it was something like $1 to index their content. So if we hit re-index the site because we changed something, then
I see.
There.
Perfect.
Okay, thank you.
One last question.
Yeah.
Ame?
Yeah, hi. Thank you. Very nice presentation. Very exciting. So my question is, does it work with content that are not in English? Because all the search you did was based in English. So, for example, a site that is defaultly Norwegian or German or like any other language that is not yet translated, will the same search work for it?
Yeah, actually, I should have searched for some things in other languages because I do have in this site because I'm also maintaining the AI translation management module. In my demo site, I've actually got a bunch of translated content, and it does do fine. Even if you search, let's say, in a different language, you could get results in the other language, or vice versa. So you can configure that within views. The only thing I would say is different large language models are better for different languages. So OpenAI is decent at like the kind of bigger languages like Spanish, French, German, things like that. It's, at least from my experience, has been fine. But if you get to like a very specific language from a specific country, you may want to use a model that's actually trained on that language, more specifically. So And you could use OpenAI to help you find a model that would be appropriate for your language. For
Okay,
example.
so and is it possible to couple it with maybe the AI language translation? So you have your search in your native, let's say German or narration, then the results comes back and it's translated into any other feedback.
Yeah, exactly. Because basically the semantic meaning of an article about trains in German has the same semantic meaning as the article about trains in English. So it actually doesn't really care what language you search in, because ultimately those result in the same sort of coordinates in the vector database.
Oh,
So
amazing.
yeah, it's a good advantage to be able to find content across languages, definitely.
Okay, thank you very much.
Amazing. Well, Scott, thank you so much for your time and presentation today. It's awesome, and we'll be sharing the recording tomorrow-ish. Would be our goal to get that out on Meetup and up on YouTube on our channel. So thank you so much for your time today. It's been awesome.
Awesome. Thanks very much for hosting.
Thank you. Take care. Have a good afternoon.
Bye.